Okay, so hi everybody, I'm Karsten, and I'm going to present our work on autonomous safety barrier inspection in construction. And in this, we have an approach using UAVs and SafeBIM. Yeah, okay, so a quick agenda for this presentation is that I'm going to present our motivation for the research, then our background as well, and then our research questions along with the contribution. Then I'm going to present our framework, which is consisting of prior knowledge, data acquisition, data analysis, and I'm going to end this presentation with a conclusion and briefly describe our limitations. So first of all, the motivation for our research, and we have a problem, and that is that the reality not always reflects the plan that we have that we have created upfront. Another thing is that the construction is dangerous, and these two matters means that we need some inspection in the construction site, and this is a labor-intensive task, especially when the construction site is covering large areas. Another thing here is that the hazards can be introduced over time gradually, and the inspector may be becoming blind to these over time introduced hazards. Another thing again here is that safety duration is based on the progress of the construction site, so we need to have like a relatively high temporal resolution of the inspection. So in our work here, we propose a solution which include autonomous approach, and we base this on point cloud data analysis, and the point cloud is collected by the UAV. So some background here, based on the Bureau of Labor Statistics, we can see here from the report of 2019 that 21.6% of all fatalities was in construction. And that 33.5 were corresponding to fall hazards. And this is why we are interested in the fall hazards at the construction site. Then we can also see here that that UAVs are already applied in the construction site. I have brought along some examples here where we have some manual investigation of inaccessible locations based on the video and photos from the drone. Also, we have an example here where visual markers are placed on the guardrail in order to inspect those. The last here is an example of a mock-up situation of a guardrail and a hole, and the drone is used to find these hazard situations. So in our approach, we try to approach the complete construction site, but we do this in a simulation environment, and we do collect the data, and we detect the detection of guardrails for the autonomous inspection. So our research question, the overall one is if it is practical to utilize autonomous UAVs for assisting safety inspection for guardrail systems in construction. And if we try to break these down to more digestible questions, the first one is to figure out if it is reasonable to use UAV in point cloud to ease the task of safety inspection. And the second one is if it is practical to drastically improve the temporal resolution of this inspection. So our contribution with this work is that we have this simple, intuitive approach for guardrail detection and post-estimation. And with this, we can utilize this autonomous inspection approach, this means that we can improve the occupational health and safety in the construction site. So here is our proposed framework, which is consisting of three main parts, so to speak. We have some prior knowledge which contains rules, the safety rules, and then we have three building models. The first one is empty, safe, and unsafe, and I'll come back to this. Then we do some data acquisition in the gazebo environment, and here we have, of course, the model and the environment, and also models for the sensor that is placed on the drone, which we also have a model for. Then Last but not least, we do some analysis, which contains some ground plane estimation, guardrail extraction, and post estimation. So if we look into the first part of the framework, I've tried to frame this up here in the illustration here. Then we have the safety regulation, and we base our work on the German safety regulation here, BG BAU it is called, which describes when to use it. That's the leftmost figure, and the figure to the right here is how to adhere to this rule. So then, as I mentioned, we have the building model, and here we have the empty building model, and we are doing this work on a 10-story high-rise building. And then we create the safe version of this, and we do this based on the rule that I just showed. So we have now added all the guardrails needed for this building to adhere to the safety regulation. And then we create a model that we call unsafe, which is a representation of the reality in our simulated environment. Here we have altered some of the guardrails, so the safe version guardrails are altered in these different variations that we see here in the figure on the right. So the next part is the data acquisition, which, as I mentioned, was done in Gazebo. So here we again have the model that we place in the Gazebo environment. We have a drone where we have the model of its physics and also a model of the sensor, which in this case is an RGB depth camera. And then we have a path that the drone should fly, and this is based on our prior knowledge, because we have a safe BIM model. So we know actually where the guardrails should be installed, and we can fly the same path in order to inspect those. And in the video that runs here on the right, we can see how the drone is actually capturing the point cloud, and this is obviously speeded up in order to show it here. So the last part is consisting of, in this example here, we have the empty model that we first start to capture, and then we have the unsafe afterwards. The safe model, we start with a ransack algorithm for plane fitting and try to find the ground plane in order to have the zero. Then we collect a point per feature and put this into a hash table that we can later use for comparison. Now we have these two things, and now we can actually go and collect the reality. So the unsafe model is now placed in the environment, and we create this point per feature for the unsafe environment as well. Now we do the matching to the hash table that we have just created, and we do this point per feature mapping, hash mapping to the closest point. Then we compute the pose between the points, and we do a hot transform where we can, which is a voting scheme to the template that we have put in, so the empty model, and by that we can figure out which of the points belong to the model that we have put into the system. As the hot transform is discrete, we use an iterative closest point algorithm to fine tune the translation that we are ending up with. The same goes when, so this was for the model, so to remove the building model. So next up is, of course, to try to find where the guardrails are. And now we can remove the points belonging to the model and only concentrate on the guardrails. So this is the same process for those. On average, we found that we could do this process here with a translation error of 1.36%, and the rotational error of approximately 1%, which is relatively good. So to conclude, if it is reasonable to use UAV and point cloud to ease the task of safety inspection, we think yes. We detected and post-estimated the guardrails of the high-rise building, which was done with the simple intuitive approach. We can thereby say that we will sometime improve the occupational health and safety on the construction site, but we have some limitations here that this is only proven in our simulated environment, and we have not yet classified all the hazard situations and propose the corresponding mitigation for the health and safety environment expert. So the last research question is here that if it is practical to drastically improve the temporal resolution, which we was figuring out that we needed. And yes, we did this inspection here in approximately 1 hour. So we do this in an automated inspection approach, which means that we can do this continuously nearly. But we have not yet implemented that the drone should go back to recharge, so not automated service yet. Thank you. This concludes my my presentation. If you have any question, I'm happy to answer them.